Good day everyone! Today, I will be showing you the common laboratory techniques that you can use in conducting different experiments from basic to complicated ones safely. First things first, in conducting any experiments inside the lab, we should have our personal protection to ensure our safety. So, we should wear proper laboratory attire at all times. First, and one of the most important to wear is our laboratory gown or laboratory coat. It serves as a barrier that keeps you from being exposed to accidents in the lab. Always remember to wear long pants or skirts and closed-toe shoes, and tie back long hair. Wear safety glasses and appropriate gloves at all times. Today, I will be showing you two parts of common laboratory techniques. Part A would be handling liquid chemicals, and Part B, handling solid chemicals. Now that we are all set, we can now start our activity. Let's go! Handling liquid chemicals. First, opening a reagent bottle with a glass stopper. Remove the glass stopper by holding it in between the fingers of the hand used to grasp the reagent bottle. You can also do this. Never lay the stopper downward from a reagent bottle on the laboratory bench. Impurities may be picked up and thus contaminate the solution when the stopper is returned to the reagent bottle. Also remember to just pour the amount of reagent you need. Never return excess chemical into the reagent bottle. Transferring liquids to another container. To transfer a liquid from one container to another, hold a steering rod against the lip of the container holding the liquid, and pour it down the rod, which should touch the inside wall of the receiving vessel. If you have a hard time doing this, you can also use your two hands by holding the steering rod on one hand and the container to the other. Put the steering rod inside the other container and make it as the guide of the liquid you are pouring as shown. Reading the volume of a liquid. For reading the measurements of liquids in graduated cylinders, pipettes, burettes, and volumetric flasks, the solution's volume is read at the bottom of the meniscus. Read with the eye horizontal to the liquid surface. A clear or transparent liquid is read more easily by positioning the top edge of a black mark just below the level portion of the liquid. The black background reflects the bottom of the lower meniscus and better defines the liquid's level. Substituting a finger for the black mark will work, but not as effective. In this case, the bottom of the meniscus is sitting on the 6 ml line, so the volume of the liquid is 6 milliliters. Testing for the odor and taste of chemicals. Chemicals should not be tasted nor tested for odor unless specifically directed to do so. Working with toxic vapors must be done in a ventilating hood. To test the odor of the substance, waft a bit of vapor towards the nose as shown. Do not inhale the vapor directly from the test tube. Never hold your face directly over vapors. Heating liquids in a test tube. The test tube should be no more than 1/3 full. Position the test tube in a 45 degrees angle. Move the test tube circularly in and out of the flame, heating from the top to bottom. Never fix the flame's position at the base of the test tube. Never point the test tube to anyone. The contents may be ejected violently if the test tube is not properly heated. Heating liquids in an Erlenmeyer flask. An Erlenmeyer flask less than 1/4 full may be heated directly over a flame. Hold it with a piece of tightly folded paper or flask tongs and swirl it gently. Do not place the hot flask on the laboratory bench. Allow to cool by setting the flask on a wire gauze. If the flask is more than 1/4 full, you can also put it on a wire gauze and a tripod. Put boiling chips or glass steering rod to avoid the problem of bumping. Remember to always use a rug or heat-resistant gloves when touching the flask to protect yourself from being burned. Heating liquids in a beaker. Support the beaker or flask in a wire gauze. To avoid the problem of bumping, which is the sudden formation of superheated liquid near the flame, place a glass stirring rod or use boiling chips in the beaker. Position the flame directly under the tip of the stirring rod. You can also place a second supporting ring around the top of the beaker or flask to prevent it from being accidentally knocked off. Again, remember to protect your hands from being burned by using a rug or heat-resistant gloves when touching the beaker or flask. Heating liquids in a hot water bath. Hot water bath is done when heating flammable chemicals that might combust if exposed to open flame. It is also done for a small quantity of solution that needs to be held at constant temperature over a period of time, and for equal distribution of heat to the sample. Place the test tubes on a beaker that is 1/4 filled with water. Put a stirring rod to avoid bumping and a thermometer to monitor the temperature. After the desired temperature and time, put out the flame and transfer the test tubes to a test tube rack and leave the beaker on the wire gauze until it cools down. Evaporation of liquids. For non-flammable liquids, they may be evaporated from an evaporating dish with a gentle direct flame or over a steam bath as shown, which is more efficient rather than rapid boiling. Do not forget to avoid breathing vapors. The solid substance which remains in the dish after evaporation is termed as the residue. Handling solid chemicals. Decantation. Decantation is a process involving the separation of liquids from solids and other immiscible liquids by removing the liquid layer at the top from the layer of solid or liquid below. You can decant the liquid by allowing the precipitate to settle at the bottom of the container. Tilt the container and slowly pour the liquid to the other container until no liquid is left. This process can also be used to separate two liquids that do not mix with each other, for example, oil and water. When we leave the mixtures of oil and water, two separate layers are formed, with water at the bottom and oil being lighter at the top. We can remove the oil layer from the top by pouring it into another vessel, which leaves us with the water layer at the bottom. Gravity filtration. Gravity filtration is generally used when the filtrate, which is the liquid that has passed through the filter paper, will be retained, while the solid on the filter paper will be discarded. To filter gravity a mixture, we will use a folded filter paper. Folding a filter paper. First, fold the filter paper in half, then fold it again in half as shown. Next, put the stacked filter paper in 3 layers on one side and open one layer on the other side to form a funnel. Tear off the tip of one corner. The tear enables a closed seal to be made across the folded portion of the paper. The filter paper should be smaller than the funnel. Pour some water into the mouth of the funnel to wet the filter paper. It is necessary to wet or moisten the filter paper to secure it to the bottom of the filter funnel. Do this using the solvent to be used in the filtration and press the top of the paper against the funnel all around its circumference to seal the space between the funnel wall and the paper. Without this step, the filter paper may float when the solid solvent mixture is poured. Consequently, solid product is lost as it passes around the filter paper, ending up in the filter flask below. Before filtering the mixture, allow the solid to settle to the bottom of the beaker. Then, carefully decant the supernatant liquid through the filter. This is done to prevent early accumulation of precipitate on the filter paper, which would slow the filtration process. Transfer the bulk of the solid during the last stages of the filtration process. If the precipitate needs to be washed, the washing is mostly efficiently done while the solid is still in the beaker. The major transfer is done with the last wash. If the solid is to be saved, remove the filter paper carefully and place it on a watch glass to dry. Remember to be cautious because wet filter paper tears easily. Do not forget to clean your working area every after experiment to avoid accidents to happen. and to also maintain the cleanliness of our laboratory.
Thank you for watching. I hope you learned something today. Always remember, knowledge is power.